Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study the basic nature of amines. Okay, fine. So in the basic nature of amines, first thing we'll study about the gaseous phase. That how to arrange different amines in the increasing or decreasing order of their basic strength in the gaseous phase. So we have primary amine, we have secondary amines, and we have the tertiary amines. As we all know that amines are stronger base as compared to ammonia, and that is due to the presence of this alkyl group, which is an electron donating group, which increases the electron density on the nitrogen atom, due to which it can act as a stronger base as compared to ammonia. Now in the gaseous phase, as we can see in the primary amine, which is 1 degree amine, we have one alkyl group which is attached to this nitrogen. And the nature of this alkyl group is electron donating. Electron donating group. So it increases the electron density on the nitrogen atom, increasing its basic strength. When we move to the secondary amines, we have two alkyl groups attached to the nitrogen atom. So they will further increase the electron density on the nitrogen atom. And in case of 3 degree, that is a tertiary amine, we have three alkyl groups which are attached to the nitrogen atom, which will increase the electron density on the nitrogen, due to which this nitrogen is able to donate the pair of electron much easily as compared to secondary and primary amines. So we can say that in the gaseous phase, tertiary amine is stronger base as compared to secondary amine, and secondary amine is a stronger base as compared to primary amine. So increasing order of basic strength of amines, in gaseous phase is 1 degree, which is less than 2 degree, which is less than 3 degree. So this will be the order of basic strength in case of amines in gaseous phase. But when we talk about the aqueous phase, second comes the aqueous phase. Means when these amines are dissolved in water. So in the aqueous phase, amines reacts with water to form ammonium ions plus OH negative ion. And there are three factors which will govern the basic strength of amines in the aqueous phase. So what all the three factors which we should keep in mind are: number one is the inductive effect. Of alkyl groups. Second is the solvation effect. And third is steric influence. Steric influence to hydrogen bonding. These are the three factors which we should keep in mind when we arrange amines in increasing or decreasing order in aqueous phase. Okay, so let us take first an example. RNH2, this is the primary amine. We have NHR, this is the secondary amine, and RNR, this one is a tertiary amine. Fine. So according to inductive effect, we have the order. According to inductive effect, we have the order primary, then comes the secondary, and then comes the tertiary. Second, according to solvation effect, we have the order. Now, primary amine is the most solvated. Okay. And tertiary amine is the least soluble because it has 3 alkyl group attached on the nitrogen atoms. So after reacting with water, it's only gain 1 hydrogen atom on it. So it can form only 1 hydrogen bond. Whereas in case of secondary, it can form 2 hydrogen bond and primary can form 3 hydrogen bond with the water molecule. So it means the most solvated amine is the primary amine and tertiary amine is the least solvated. So we have the order 3 degree, then comes a 2 degree, and then comes a 1 degree. It means the effect or the order which we get in the solvation effect is just the opposite of the effect which we have obtained in the inductive effect. So they are going to decrease the basic strength of primary and tertiary amine, both as both the effects are just opposite to each other. But the secondary amine is going to get the benefit of it. So whenever we are going to arrange any primary, secondary, tertiary amine in increasing or decreasing order, so we need to figure out which amine is the most basic. So that would be a secondary amine. Then comes the role of the third factor, that is steric hindrance. Steric hindrance to hydrogen bonding. Hydrogen bonding. In this, when we are having small alkyl group, like that of methyl group, CH3, this methyl group do not produce any steric hindrance to hydrogen bonding. Do not produce any steric hindrance. To H bonding. So if we have the methyl substituted amines, like if you have this CH3 and H2, we have CH3 whole twice NH, we have CH3 whole thrice and let us take ammonia along with it. Okay, so out of them, the most basic would be the secondary amine. So when we are going to arrange them in the decreasing or increasing order of the basic strength, so let us arrange them in the decreasing order of the basic strength. So most basic will be the secondary amine, which is CH3 whole twice NH. This one is the most basic. After that, as we have come to know that CH3 do not produce any steric hindrance to hydrogen bonding, it means our solvation is dominating the inductive effect. If solvation is dominating the inductive effect, then the primary amine will be more basic. Then comes the tertiary amine. And then comes the ammonia, NH3. As ammonia is weaker base as compared to all our aliphatic amines. But if we change the group, alkyl group, from methyl to ethyl, if we change the alkyl group from methyl to ethyl C2H5, then there will be a change in the order of the basic strength of amines. And let us take the example of ethylamine. So we have C2H5NH2. We have C2H5 whole twice NH. We have C2H5 whole thrice N. And we have the ammonia, NH3. So first of all, the secondary amine would be the most basic amine out of them, as we have studied earlier. So let us write down the secondary amine as C2H5 whole twice NH at the first position, most basic. After that, we have to go for or look for the alkyl group. Now, in this case, we are having ethyl as the alkyl group. Now, when we change this methyl group to ethyl group is going to produce steric hindrance to hydrogen bonding. So that's why our inductive effect dominates the solvation effect. If inductive effect dominates the solvation effect, it means our tertiary amine gets more basic as compared to primary amine. So first comes the tertiary amine, then comes the primary amine, and then comes the ammonia. It means there is the subtle interplay. Subtle interplay means mixing of all the three concepts, which means inductive effect, solvation effect, and steric hindrance to hydrogen bonding. Most of the people take it in a different manner, the steric hindrance. Steric hindrance to what? They don't know how these are groups going to affect the basic strength, or how the steric hindrance are going to hinder the basic strength. So it becomes an important factor in the aqueous phase when we dissolve these amines in the water. So steric hindrance to hydrogen bonding. We have to look for the steric hindrance to hydrogen bonding, whether the group is able to produce steric hindrance over there or not. When the group is small, like methyl, it do not produce any steric hindrance to hydrogen bonding. But when we change the group from methyl to ethyl, it start producing steric hindrance to hydrogen bonding, and that changes the order of the basic strength of amines. So this is the basic strength of amines, or you can say ethylamines in the aqueous phase. If we talk about the basic strength of aromatic amines, so please remember aromatic amines are weaker base as compared to ammonia. Why so? This is due to the reason that the lone pair present on nitrogen atom in aromatic amine is involved in resonance with the benzene ring. This lone pair is involved in resonance. And if this lone pair is involved in resonance, it won't be available on this aromatic amine to be donated to any other species, it means it would be weaker base as compared to ammonia. So all aromatic amines are weaker base as compared to ammonia. If we increase the number of aromatic rings attached to the nitrogen atom, for example, if we take this compound and then we will have two benzene rings attached on the nitrogen, that is the secondary aromatic amine. And likewise, if we take this tertiary aromatic amine, then the primary aromatic amine will be most basic, then comes the secondary, and then comes the tertiary. So this will be the order of the basic strength of aromatic amines. Hope this helps.